Our next speaker is Effie from Repsol, going to talk about the hydraulic intervention workover unit.
Thank you, Chairperson. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to all of you. I am Effie, a completion engineer from Repsol, and today I will deliver my topic entitled Cost-Effective Approach to Offline Plant Abandonment with the Hydraulic Workover Unit. Actually, this cost-effective approach is another word for the cheap version of a P&A. So if you can see on the screen, those pictures were taken during actual operations of plugging abandonment that we did last year on BKC platform. So that's the picture of the casing hanger that we pull out with the casing hanger running tool and with the EMAS hydraulic workover unit. That's the suspension cap that we put at the end of abandonment job for each wall. That's the surface cement sample. That's the crew rigging up the cradle and the fluid transfer lines to transfer the oil base mud behind the 958 production casing into the vessel for safe disposal at the base. And that's the complete rig up of the hydraulic worker unit, 500,000 pounds from EMAS Energy. If I have some time left at the end of my presentation, I will flash through some of the pictures that taken during the operations last year. I do not have a safety moment to start off with my presentation, but I would like to share with you some safety statistics from our 2018 offline rigless P&A campaign. So if you can see on the screen, so we spent about 90 days last year to P&A about 5 wells, which involve 62,000 of man hours, produced about 2,300 stop cards, and 4 stop work authority. If you can see the equipment layout that I had on the screens, the equipment or the platform were crowded with all this hydraulic workover unit equipment. And the spacing between the equipment is just enough for the personnel to work and evacuate in emergency situations. And the bottom right diagram shows how packed the vessel was when the vessel arrived at the platform to offload the hydraulic workover unit. I can't recall the specific number, but it's in the range of, I think, we did about 50 to 70 lifts to offload all this hydraulic workover unit equipment from the vessel and to the platform and backload to the same vessel again. So given the platform is small, with crowded equipment, with many overhead liftings and high number of man hours involved, we successfully brought everybody home to the shore without lost time incidents, without any medical treatment and restricted work cases, no high profile incidents, no hydrocarbon releases. All base mud behind 958 production casing were safely transferred into the vessel and disposed at shore. No regulatory violations. So next. So back in 2017, fourth quarter, we were challenged by our management team to look for ways to drive this infill drilling campaign cost down. There were no new slots on the platform, and that means we have to P&A the existing wells which were idle, and we need to sidetrack from those donor wells. So the original assumption was to P&A the donor wells with drilling rig. But we looked at the donor wells and decided that the wells could be P&A offline with 2 different phases, one with well servicing unit and one with the hydraulic workover unit. So the donor wells that we identified were quite straightforward. Those were single string completion with a single reservoir. Other than that, we also have done a similar offline P&A operations in the past, up until tubing recovery. So we had some data from our Talisman Legacy Time. So we studied those operations back then, which were executed in 2009, look at the world configurations, scope of works, and what happened during the operations, and most importantly, the lessons learned that captured during the operations. All those data and information were provided to Halliburton as part of our collaboration with them to deliver this offline P&A campaign. And as a result, further cost efficiency could be achieved by segregating these campaigns into 2 phases. First, we have a phase 1 dedicated with a well servicing unit supported with a small accommodation boat with scopes to bullhead and squeeze cement into the perforation to establish as a first barrier, spot cement plug above production packer as a second barrier, and cut tubing shallow below 958 production casing top of cement. So once phase 1 is done for all the donor wells candidates, we would have a hydraulic workover unit mobilized to the platform with accommodation vessel and a supply vessel to pull the completion tubing, lock top of cement barite, cut and pull 958 production casing, and set shallow plug and install the wellhead abandonment cap. If you can see, phase 1, we managed to achieve a cost effective by segregating the scope of work of a hydraulic workover unit when focused into the phase 2 of the operations. So after we completed all the defining the scope of works, we awarded the campaign to Halliburton under Integrated Idle Well Restoration, IIWR contract. So all various services such as E-line, cementing, and project management were provided by them. So we were able to leverage the knowledge, technology, experience, and technical expertise by different services within Halliburton. And not only that, the one down, all down concept and zero rate due to wet on weather, if a DP2 vessel was deployed, were key critical elements that we decided to use this IIWR contract to execute this plug and abandonment campaign. So during the course of preparing the campaign, we compared the P&A cost with drilling rig and a rigless hydraulic workover unit. And the cost in our situation is much cheaper to do this P&A with HW, simply because the spread rate of the HW is 25% of our drilling spread rate. So we decided to execute this offline P&A in 2 phases, kept the cost as low as possible. So first phase, which involved E-line and pump, and second phase involved hydraulic workover unit with 500,000 pounds of pulling capacity with E-line and pump, which remained from the phase 1, and with additional accommodation vessel to support the operations. So in the end, we managed to keep our operations of uptime 86% with a 14% NPT, and we managed to the P&A almost all the donor wells that we plan to P&A. So this chart shows some performance analysis that we did in terms of duration for each well that during the phase 1 P&A. Please don't put too much attention or details into the numbers that I have on the chart. But what I would like to summarize from this chart is that it's very tough for us, for Repsol to get a smooth operations without having to deal with equipment and well issues. For example, in BKC10, we had to incur close to 6 days of NPT due to vessel issue. But due to this contract is under IIWR one down, all down concept, so that 6 days of NPT was discounted. In BKC8, we encountered some slick line issues and severe losses into the perforation during the cementing squeeze operations. So what I'm trying to tell you is that the key lessons learned that we gathered from this phase 1 operation is that we need to verify the tubing integrity prior to this campaign and injectivity test so that we would know what to react during the actual execution of the plug and abandonment job. And of course, when we started this P&A campaign last year, we had to deal some unknown of unforeseen issue in BKC34, which resulted us to come up with a potential candidate which we P&A during the phase 2 operations, which cost us more in terms of overall infield drilling campaign. So this chart shows performance analysis in duration for phase 2 of the plug and abandonment campaign. Again, please ignore all these numbers on the chart, as they are intended to confuse you actually. So if you can see these bar sections, so we suffered about 5 to 6 days of NPT due to bad weather. But given the situation that we deployed DP2 vessel into the field, so those 6 days of NPT was discounted from the actual cost under IWL contract. So the key lessons learned that we gathered from this phase 2 operation was when we did the planning job for this offline P&A campaign, we were too optimistic on estimating duration for the rig up. So now we know that 7 days is more realistic compared to 4 days initially. We mobilized alternative 958 casing cutter that can provide indication that the cut has been made, which we learned from BKC8 phase 2. We took quite a while, we spent quite a while amount of time to cut and recover the 958 casing in BKC8 and to execute the offline P&A campaign without any interruptions. Delays in phase 1 and phase 2 have caused the campaign to prolong until the total field platform shutdown, which we have to demob and came back after 40 days to complete the rest of the campaign. And of course, that incur more costs to the P&A cost. In terms of the cost, it's quite obvious that we spend more in phase 2 because we had a hydraulic workover unit and a bigger vessel that supported during the operation. If you can see the phase 1 cost, we could have spent lesser costs if this was not due to BKC 17, which we had to do phase 1 abandonment during when HW is being there on the platform. And we spent less for phase 2 for BKC 10 because there was an obstruction between the platform crane and HW. So we decided not to do a BKC 10 and drop it from the campaign. So that's the kind of like idea of the total cost spent by well. So in the end, the results that matter the most, which is the savings. So based on the execution of the campaign, we managed to save about close to 4 million versus originally estimated at 5 million. That's why our partners, Petro Vietnam and Carigali Petronas, were barely smiling. But in the end, they were satisfied with our results. So this is the offline P&A for Repsol Malaysia and Global for slot recovery and rigless. And the P&A wells were successfully drilled and completed recently in April and brought increased production to our field. So I think I still have some time left, so I'll just flash through some of the pictures that taken during the actual operation. So those two are the skid beams that loaded and lifted during we were finishing the phase 1 operations. So we welded the skid beams onto the BKC platform. So this HW unit, they came in modular sections. So it's kind of like building them stack by stack. So we started by the bottom and go on to the top. So that's the Jeep crane stand. We spent a lot of time trying to wait for the fine weather to get this up to the platform and install at the back of the hydraulic workover unit. So that's in progress of stacking up all those different blocks of the HW. So this Jeep crane also causes some difficulty on getting at the top of the HW because it weighs about close to 12 to 13 metric ton, which is close to the lifting capacity of our platform crane. And that's the complete setup of our HWU on the BKC platform. That's the look of the HW from far away. So we started the operations by nipple along the tree, rig up riser, BOP. So we remove the tubing head, rig out on the casing head, the riser. This is the type of casing cutter that we run in hole. And after a few attempts to make a few shallow cuts on the 958 production casing, we managed to get this 958 production casing out. So that's some evidence of the, I would say, contaminated cement behind that 958 production casing, and that's the abandonment cap that we put on after we completed the P&A job. So that's basically the operations that done to stack down and demop the HW equipment back to shore. If you can see, we used two different vessels. Those two vessels were packed, and if you can imagine, we had a lot of overhead liftings, dangerous liftings, oversized liftings happen offshore during the operations. I guess that's all from me. Thank you for your attention.
That's great. Thanks, Effie. And congratulations on that HSE record. 50 or 70 lifts going on off a platform, and it's a great achievement. So well done.
Thank you.
I have a question similar to what I asked Tio. So going through this plug and abandonment sequence, and obviously you're going to now you went and drilled some more wells. Is there any lessons or anything that you turn around and tell the drilling engineers who are designing this new well, hey, this time, can you do something different so that when we come and P&A it, it's going to be easier? Are there any lessons there? Or do you see that as an avenue to get the drilling folk more engaged on the P&A?
Yes, I believe that there is an avenue since I did this P&A myself last year, and I am in completion team, designing the completion, putting the completion into the wells that the drilling guys drill. So yes, there is avenue, but those lessons learned that we captured during the recently operation, they were not so much involved onto the well design. They are more onto operations. So yes, I believe there is avenue, but we had not done a lot of P&A campaigns in the past. This is like a second campaign that involved 4 wells, so we need more experience and data before we can do some change in design.
Any a question over there?
Hi, my name is Nora. I'm from Shell. My question is probably not clear in the presentation. You did mention that you brought in a unit during the first phase, and you pumped cement through the perforation. So I assume that will be the reservoir section?
Yes, exactly.
Okay.
You're right, yeah.
All right. So what method do you use during that time? Because it's not clear to me. Are you using cold tubing or you have any other methods?
Like I mentioned to you from my slides, the completion configuration that we had was quite straightforward. They are all a single zone, single string. So we use a cementing unit to squeeze cement into the perforation using the existing tubing string.
So it's a bullheading method from surface?
Yeah.
Okay.
Hi, my name is Jusni from MPM. I just want to add a comment about well planning for the intervention and also P&A, like Mr. Chairman was asking just now. The avenue is obviously, as a regulator, we always have the avenue to actually demand this kind of question in our WMRC, which is is a gate where they would present their well design. For drilling and completion, we always challenge this kind of the well completion design to make sure that accessibility and P&A design in later stage, 10 years, 20 years, is taken care of. So that's the avenue from regulator side, and that is basically would actually embark into their internal planning.
Yeah.
That's great to hear because it's not happening in every other country. So
well, it's happening.
Well
here.
done. That's good to hear. Thank you.
Okay.
We had another question over here.
Okay, my name is Sukarmin from Saka Energy Indonesia. One question, come back again with the phase one. You mentioned about the P&A, pre-P&A, I call pre-P&A. So you did pumping cement through the bullheading, everything. Yeah. So my comment is, like you mentioned, previous one, your compression is only single.
Yes, that's right.
But anyway, in the P&A, we need to ensure the cement itself is proper to isolate the joint itself. So how to control if you're doing by bullheading, cementing? That's the first one. Second one is my advice. If I looking from the all operation you did is great. You already some achievement to reduce the cost. But again, in the future, my advice is it's not necessary for us to select bigger hydraulic workover unit.
Oh,
you
right.
use 500K, right? So it's huge capability because the phase 2 I show here is you just only pull compression tubing, which is can use only 2 to 5K only, or 340. 340 itself is already huge for the capability itself. So we have some room, gap for improvement in the future. The first one is the using by the hydraulic workover unit itself, the capability. The second one is utilization of the DP. It's not necessary for me to also in your operation is using DP. Yeah. You can use this the boat, the normal pressure boat, just only to put everything just for accommodation. It's not necessary for us to use DP. So you have more room for reduce the cost.
Yes.
But this is my opinion. So again, one question for me is the phase one. You need to improve for the methodology itself because I didn't see the P&A correct method in here. Yeah. Yes. Okay. Thank you.
Yeah. Sorry. So the purpose of my presentation title is to to deliver kind of like a cost-effective approach. So I try to focus more on how we segregated the phases into different phases to avoid the high cost of hydraulic workover unit being part of the cost. So to answer your question, yes, you're right. You have a point. The 500,000 pulling capacity of HW seems to be overkill for this project. But I would like to correct you. For our scope, we extended the P&A scope up until cutting and recovering of 958 production casing. So I think we had to sidetrack in these 4 donor wells. The sidetrack depth is as deep as 1,200 meters, 1,300 meters. So the total weight of the production casing for 958, I believe it's somewhere around 200,000 pounds, which we had the data in the previous campaign back in 2009, where drilling rig, was used to pull those 958 production casing. So they even pull up until 500,000 pounds, the maximum cantilever rating of the rig, which they did not manage to pull it out. So they need to make a shallow cuts for them to recover that 958 production casing. So we work, our unit selection was work based on that lessons learned we captured from the 2009 data.
That's great. And what I'm hearing is, use the lightest tool in the toolbox. Hey, there's some contingency. Yesterday we had NOV saying, hey, we've got this tool in the toolbox, an agitator tool, which can help in this sort of instance. So perhaps there's a nice middle ground there for using a lighter unit, throwing some more technology at it, you know, and maybe saving even more.
Yeah, that's right. When we talk about the P&A, we wanted to, you know, to deliver this P&A at a very, you know, cost-effective cost, very cheap. Yeah, I would say it, you know, as much as I hate that word. But you know, other than that, we need to think about the chance of success as well to be considered when dealing with this P&A campaign.
This is great. There's no other question. This is really neat seeing these case histories and exactly what worked, what didn't work, and things like this. It's extremely valuable for the crowd here. So, if no further questions, I'd like to thank Effie for his presentation and sharing.
Thank you.